Imagine a world beneath the waves, so vast and alien that over 95% of it remains completely unexplored. A place where sunlight never penetrates, where the pressure could crush a submarine, and temperatures hover just above freezing. This is not science fiction, this is the deep sea, the largest habitat on our planet, yet the most solitary and least understood. Today, we embark on a journey into this extraordinary realm, to uncover the secrets of what truly hides in Earth's deepest, darkest corners. So, what exactly defines the deep sea? For scientists, it begins beyond 200 meters from the surface. This invisible line marks a dramatic boundary. It's the point where sunlight, which powers nearly all life on Earth through photosynthesis, can no longer effectively penetrate. Below this depth, the ocean transitions from a vibrant, sunlit world into a perpetually dark and cold environment. This vast, dark domain extends all the way down to the deepest oceanic trenches, plunging thousands of meters further into the Earth. One of the most profound challenges of the deep sea is the immense pressure. Imagine the weight of the entire ocean column pressing down on you. At the deepest points, this pressure is staggering, exceeding 1,100 standard atmospheres. To put that into perspective, it's equivalent to having 50 fully loaded jumbo jets resting directly on your head. This incredible force requires any life forms, or indeed any human-made vessels, to possess extraordinary adaptations or structural integrity just to survive, let alone thrive. Beyond the crushing pressure, the deep sea is also defined by its frigid temperatures. Far from the sun's warming rays, the vast majority of deep-sea water remains at a near-freezing chill, typically hovering between 0 and 3 degrees Celsius, or 32 to 37 degrees Fahrenheit. This constant, icy embrace creates an environment where metabolic processes are often slowed, and life must conserve energy diligently. It's a stark, cold reality that shapes the very existence of everything that calls these depths home. However, there are extraordinary exceptions to this frigid rule: hydrothermal vents. These geological marvels are fissures in the Earth's crust, typically found along mid-ocean ridges, that spew superheated water into the surrounding ocean. This water, heated by magma beneath the seafloor, can reach astonishing temperatures, sometimes exceeding 400 degrees Celsius or 750 degrees Fahrenheit. These vents create oases of warmth and chemical energy, forming unique ecosystems that defy the cold, dark conditions of the rest of the deep sea. The existence of life around hydrothermal vents introduces one of the deep sea's most fascinating biological phenomena: chemosynthesis. Unlike the surface world where photosynthesis uses sunlight to create energy, chemosynthesis is a process where certain bacteria convert chemical compounds, like hydrogen sulfide emitted from the vents, into organic matter. These chemosynthetic bacteria form the very base of the food web in these ecosystems, supporting a diverse array of life where sunlight is completely absent. It's a fundamental reimagining of how life can exist. The deep sea hosts an astonishing diversity of life, each species exhibiting unique and often bizarre adaptations to thrive in these extreme conditions. From specialized sensory organs to bioluminescent lures, these creatures have evolved remarkable ways to find food, attract mates, and evade predators in a world of perpetual darkness and scarcity. Their existence is a testament to life's incredible resilience and adaptability, pushing the boundaries of what we once thought possible in the face of such overwhelming environmental pressures. One of the most iconic residents of the deep sea is the anglerfish. In the complete darkness of the aphotic zone, finding food or a mate can be nearly impossible. The anglerfish solves this challenge with a truly ingenious adaptation: a bioluminescent lure. This fleshy appendage, extending from its head, glows in the darkness, attracting unsuspecting prey directly to its gaping, tooth-filled mouth. For potential mates, the tiny male anglerfish often permanently fuses to the larger female, ensuring reproduction in this vast, solitary environment. Around hydrothermal vents, one of the most striking creatures is the giant tubeworm. These magnificent organisms can grow several meters long and have no mouth or digestive tract. Instead, they host billions of symbiotic bacteria within their bodies. These bacteria perform chemosynthesis, converting the vent chemicals into energy, which then nourishes the worm. It's a perfect example of mutualism, where two different organisms rely on each other for survival in an environment that would otherwise be completely uninhabitable for the worm itself. Another marvel of the deep is the colossal squid, an apex predator of the southern ocean depths. While rarely seen, specimens recovered tell a tale of incredible adaptation. This creature possesses the largest eyes of any animal on Earth, specifically evolved to detect the faintest flickers of light, likely from bioluminescent prey or perhaps the faint silhouettes of predators like sperm whales in the dim, abyssal glow. These massive eyes are crucial tools for navigating and hunting in an environment where every photon counts. For centuries, the deep sea remained beyond human reach. But in 1960, a groundbreaking feat of engineering and courage changed everything. The bathyscaphe Trieste, a submersible designed by Auguste Piccard, made history. Piloted by Don Walsh and Jacques Piccard, Auguste's son, this pioneering vessel embarked on a perilous journey to the deepest known point on Earth. It was an expedition into the unknown, a testament to human curiosity and the drive to explore the very limits of our planet. The target for the Trieste was the Challenger Deep, the deepest surveyed point in the Mariana Trench. On January 23, 1960, Walsh and Piccard successfully reached the bottom, a staggering depth of nearly 11,000 meters. They spent a short time observing the abyssal plain, reporting sightings of life, an astounding discovery that proved even the most extreme environments could support complex organisms. Their journey not only marked a triumph of engineering but fundamentally reshaped our understanding of life's boundaries. Years later, another crucial vessel, the DSV Alvin, played a pivotal role in unraveling deep-sea mysteries. In 1977, while exploring the Galapagos Rift, Alvin made an astonishing discovery: hydrothermal vents. Before this, scientists believed that all life ultimately depended on the sun. Alvin's discovery, and the subsequent study of the vent ecosystems, provided undeniable proof of chemosynthesis, completely rewriting our understanding of energy sources for life and expanding the potential for life to exist in similarly extreme environments elsewhere in the universe. Decades after the Trieste, the spirit of solo deep-sea exploration was rekindled by filmmaker James Cameron. In 2012, piloting his custom-built submersible, the Deep-Sea Challenger, Cameron undertook a solo dive to the Challenger Deep. His mission was not just to reach the bottom but to capture unprecedented high-definition footage and collect samples, providing a new window into this largely unknown world. His journey highlighted the continued allure of the deep and the technological advancements making such incredible solo feats possible. Despite these monumental achievements, the vastness of the deep sea means that over 95% of it still remains unexplored. Each expedition, every remotely operated vehicle, ROV, deployment, brings back new species, new geological formations, and new insights into the intricate web of life. The deep sea holds untold biodiversity, potential new medicines, and crucial ecological processes that regulate our planet's climate. The mystery is still largely intact, beckoning new generations of explorers and scientists to uncover its many secrets. Yet, even in these remote and pristine environments, humanity's impact is increasingly evident. Plastic pollution, particularly microplastics, has reached the deepest trenches. Fragments of plastic, broken down over time, are ingested by deep-sea organisms, entering the food web and potentially impacting their health and survival. This pervasive contamination serves as a stark reminder that no corner of our planet, no matter how isolated, is truly safe from the consequences of human activity on the surface. Another emerging threat to the deep sea is the prospect of deep-sea mining. As terrestrial resources diminish, attention turns to the ocean floor's rich deposits of valuable minerals, often found around hydrothermal vents or on abyssal plains. However, the potential disruption to these fragile and slow-growing ecosystems is immense. Mining operations could destroy unique habitats, generate sediment plumes that smother filter feeders, and release toxins, causing irreversible damage to ecosystems that have taken millennia to evolve. Even global climate change casts a long shadow over the deep sea. Ocean acidification, caused by the absorption of excess carbon dioxide from the atmosphere, makes seawater more acidic, threatening organisms that build shells and skeletons, like deep-sea corals. Additionally, changes in surface ocean currents can alter nutrient delivery to the depths, while ocean deoxygenation leads to dead zones where oxygen levels are too low to support most complex life. These global changes pose existential threats to the delicate balance of deep-sea ecosystems. The deep sea, despite its vastness and isolation, is intimately connected to the health of our entire planet. It plays a crucial role in regulating global climate, harbors immense biodiversity, and holds secrets yet to be discovered. Protecting this vital ecosystem means reducing plastic pollution, carefully regulating or even pausing deep-sea mining, and addressing the root causes of climate change. Only by understanding and safeguarding these unseen depths can we ensure the long-term health and wonder of our blue planet. From the pioneering dives of the Trias to the insights gained by Alvin and James Cameron, humanity has only just begun to scratch the surface of the deep sea's mysteries. Every journey into its depths reveals not only strange new worlds but also profound lessons about life's extraordinary capacity to adapt. As we look to the future, the deep sea stands as a beacon of exploration, a reminder that the greatest adventures and discoveries may lie not in distant galaxies, but right here, beneath the waves, waiting to be understood and cherished.